All right, guys, so in today's video's notes, we're going to be starting our next unit, which is Unit 3. We're going to start in the first section by talking about what are called trigonometric ratios. So we're going to talk about how you can find the sine, cosine, and tangent for any particular angle. To start off with, we're going to begin just by finding the sine, cosine, and tangent for some numbers using our scientific calculator. I've got Desmos calculator pulled up, which is a great scientific calculator to use. You can just Google Desmos scientific calculator and use it if you want to have the same calculators I have on the right side of my screen. Otherwise, feel free to use your phone. Just make sure it's turned to the side or your own personal scientific calculator, whatever works best for you. Now, it's going to be really important, guys, to make sure that your calculator is in the right mode. What I mean by that, on this Desmos calculator, there's a button which will switch it from radian to degree mode. Radian is RAD, degree is DEG. You need to make sure that it's on degree mode. And that's the same whether that's the Desmos calculator or whether that's your own scientific calculator or your phone. Make sure that it's in degree mode. Otherwise, you're going to get some very different answers when you start typing these in with me. Okay, so let's go ahead and type in the first equation. So we're going to go ahead and find the sine of 90 degrees. So we're going to type in sine, type in our 90, and it tells us that the sine of 90 degrees is equal to 1. Okay, if you got something different, like if you were to get, let's say, this answer instead, where you got 0.893996 and some more numbers, that's because you were in radian mode. Make sure to switch that back to degree mode, and that'll tell you that the answer is going to be 1. Okay, let's go ahead and type in the next one. So cosine of 15 degrees and cosine of 15 is going to be equal to 0.9659. We're going to go to the nearest tenth, though. And so for the nearest tenth, we're actually going to round that 0.9 up to a positive 1.0. Now, I'm going to put the 0.0 there just to say that it wasn't exactly 1, but that would be to the nearest tenth. Okay, finally, let's go ahead and find tangent of 73 degrees. So tangent of 73, and again, we're going to the nearest tenth, is 3.3. Okay, so let's talk about what sine, cosine, and tangent really are. So they're examples of what are called trigonometric ratios. So trigonometric ratio is the ratio of the length of two sides of a right triangle. So there's going to be basically three different ratios that we are going to look at, which are sine, cosine, and tangent. As we do so, we're going to be talking about a couple of concepts. One is called the opposite side, the other is the adjacent side. So the opposite side is the side of the right triangle, which is opposite to the acute angle that you're working with. Whereas the adjacent side is going to be the side that's next to that acute angle and is not the hypotenuse. So you're not going to be using the hypotenuse unless it actually tells you to use the hypotenuse. Okay, so starting off with the sine of the acute angle. So to find the sine, we're going to take our opposite side divided by the length of our hypotenuse. So another way we could write that to make it a little bit more simple is to just say the opposite side over the hypotenuse. And so if we want to find the sine of angle A for this first triangle, so angle A would be this angle right here, then our opposite side would be A, our hypotenuse would be C, so our sine of A would be equal to our opposite over our hypotenuse, so A over C. Now, looking at that same triangle, if instead we wanted to find the sine of angle B, this time our opposite side is going to be side B, and our hypotenuse, that will actually stay the same, that'll still be C. So if we take opposite divided by hypotenuse, that would just be B over C. Okay, next let's go ahead and talk about cosine. So cosine of the acute angle is the length of the side that's adjacent divided by the length of the hypotenuse. In other words, now you're taking the adjacent side divided by your hypotenuse. So let's take a look at this with a couple of examples. Let's start with finding the cosine of angle A. So when you're looking at angle A, we know that C is still the hypotenuse, but now we want the adjacent side. And so adjacent means the side that's actually connected to A. So not the side that's opposite, that would be side A, but the adjacent side, which would be side B. So we're going to take adjacent divided by hypotenuse, so that would be B over C. Let's do the same thing with our other triangle. So we've got cosine of angle B. This time our adjacent side would be A. Our hypotenuse would still be C. So our cosine of angle B would be equal to A over C. Okay. For our final trigonometric ratio, we're going to talk about what's called the tangent of the acute angle. So the tangent is the length of the opposite side divided by the length of the adjacent side. So a shorter way of writing that would be to write it as opposite over adjacent. All right. So let's go ahead and find that for a couple of angles, starting with angle A. Our opposite side is A. Our adjacent side we've said is B. So we're going to take A over B. That would be opposite over adjacent. That would be the tangent of angle A. If we wanted to find the tangent for angle B, this time our opposite side is side B. Our adjacent side is side A. So opposite over adjacent would this time be B over A. Now, that's a lot to try to remember, so let me give you a way to hopefully help you remember a little bit about how this works. Here's the acronym that we typically use in order to help kind of remember our sine, cosine, and tangent and their ratios. And it's called SOHCAHTOA. And so here's how that's written, SOHCAHTOA. Where the SOH, tells you that the sine is equal to your opposite side divided by your hypotenuse. So there's the O and the H. That means for cosine, where we have A and H, that would be your adjacent side divided by your hypotenuse. And finally, for tangent, that would be opposite over adjacent. So SOHCAHTOA is kind of a nice way to remember how each of the trig ratios works. So let's go ahead and use those ratios in a couple of example problems. Let's take a look. So we want to give the trigonometric ratio as a fraction for this right triangle where we've got sides 5, 12, and 13. Let's go ahead and start with angle A. So for angle A, 5 would be your opposite side, 12 would be your adjacent side, and 13 would be your hypotenuse. So remember, for sine, we want to take our opposite over our hypotenuse. That was so. And so opposite over hypotenuse, that would be equal to 5 over 13. And actually, you can't simplify that, so that would be how you'd leave your final answer. All right. Let's go ahead and find cosine next. So cosine, we're going to take our adjacent side now divided by our hypotenuse. The adjacent side is 12, divided by the hypotenuse is 13. Once again, nothing we can do there to simplify, so we're going to leave that as our final answer. Next, we'll find the tangent of A, so opposite over adjacent, which opposite is 5, adjacent is 12, so that would be 5 over 12. All right, now let's go ahead and switch angles. So we're going to switch from angle A to angle C. So for angle C, we're going to have a different set of sides. For angle C, our opposite side is going to be the 12. Our adjacent side is going to be the 5, and our hypotenuse is still going to be the 13. So now I'm using the blue labels to show the sign of those angles, or each of the trig ratios. So let's start, though, with the sine. So we're going to take our opposite side divided by our hypotenuse. So opposite is now 12, hypotenuse is still 13, so that would be 12 over 13. Next, we'll go ahead and find cosine of C, so that would be adjacent over hypotenuse. Adjacent is now 5 over hypotenuse is 13, so that would be 5 over 13. And then finally, for tangent, we're going to take opposite divided by adjacent. Opposite is 12, adjacent is 5, so that would become 12 over 5. Okay, let's go and do the same thing with our next triangle. Before we do that, notice that we're missing a side. So we're going to have to use Pythagorean theorem like we learned about in our previous unit to find that length for C. So we're going to take 9 squared plus 12 squared has to equal C squared. Let's go ahead and simplify. 81 plus 144 is equal to C squared. So that would be that 225 is equal to C squared. And then take square root of both sides. We end up with C being equal to 15. All right, so that's important because that's going to be what we'll use for our hypotenuse as we solve this triangle. Okay, so let's go ahead and start with the sine of angle W. So looking at angle W, 12 would be your opposite side, 9 would be your adjacent side, and 15 would be your hypotenuse. So if we wanted to find the sine of W, that would be opposite over hypotenuse. So that would be 12 over 15. And then make sure you simplify that to be 4 over 5. Let's go and do the same thing with cosine. So that's going to be adjacent over hypotenuse. So adjacent is 9 divided by hypotenuse is 15. And 9 divided by 15, make sure you simplify that as well, becomes 3 over 5. Finally, for the tangent, we're going to take opposite over adjacent, where opposite is 12, our adjacent is 9. Once again, make sure you simplify that to be 4 over 3. Okay, let's do the same thing with angle X. So let's relabel the sides that we need to. So 9 is now our opposite, 12 is now our adjacent, and our hypotenuse is still going to be 15. So starting off with our sine, we're going to take opposite divided by hypotenuse. So our opposite side is 9 divided by hypotenuse is 15. Once again, make sure you simplify and say that that's 3 over 5. Next, we'll find cosine. So adjacent over hypotenuse, which adjacent side is now 12 over hypotenuse is still 15. And then make sure you simplify that to be 4 over 5. Next, we're going to find tangent. That would be opposite over adjacent. That would end up being 9 over 12. And again, make sure you simplify that to be 3 over 4. All right. In addition to being able to find trig ratios like we did above, we also are going to want to be able to solve some simple equations where you've got those trig ratios in them. And this is going to be really important as we move into later sections of this unit. So let's go ahead and find each of these. So we've got on our first one that the sine of 23 equals x over 15. So we want to get x by itself, and we want to get rid of the 15. So let's go ahead and multiply both sides of our equation by 15. So that will leave us with 15 multiplied by the sine of 23 degrees is equal to x. And then once we've done that, we'll go ahead and put that into our calculator to get a decimal approximation. So we'll type in 15 multiplied by the sine of 23 degrees, which is approximately 5.9 to the nearest tenth. Let's do something similar on this next problem. So cosine of 74 equals w over 5. We just want w by itself, so let's just multiply each side by 5. So we've got that 5 multiplied by the cosine of 74 is equal to w. So now all it's left to do is type that into our calculator to get a decimal approximation. So 5 multiplied by cosine of 74 degrees, and that's going to be equal to 1.4 if we round to the nearest tenth. All right, the last one on this row is going to be a little bit different. So notice we want to try to get y by itself. But notice that there's really not an easy way to do that. We don't really want to divide both sides by 3 or anything like that. So here's what I would recommend doing. Let's go ahead and multiply each side by y. Kind of like we would if y was on top. We'll go ahead and do the same. It's just we're multiplying by a variable instead of by a number. So what that's going to do is now we're going to have y multiplied by tangent of 59 degrees is equal to the number 3. But remember, we still want to get y by itself. So what we're going to have to do, since we're multiplying by tangent of 59, is divide by the tangent of 59 degrees on both sides. That'll end up leaving us with y by itself is equal to 3 divided by the tangent of 59 degrees. All that's left to do is type that into our calculator to get a decimal approximation. So we're going to type in 3 divided by the tangent of 59 degrees, and that's 1.8 to the nearest tenth. Okay, let's see another example kind of like that. So in our next example, we've got the sine of 80 degrees equals 18 over x. So kind of like we did before, we're going to multiply by what's in the denominator for our fraction. So that's going to leave us with x multiplied by the sine of 80 degrees on the left side is equal to 18 on the right. So then to get x by itself, this is where you'll divide each side by the sine of 80 degrees. And so when you do that, you get x by itself is equal to 18 divided by the sine of 80 degrees. And now all that's left is to go ahead and put this into our calculator. So 18 divided by the sine of 80 degrees is equal to 18.3 to the nearest tenth. Now there's actually an easier way to work those types of problems where you have a variable in your denominator. If you take a look at kind of how your equation starts and then how it ends, all that you really did was took tangent of 59 degrees and y and had them swap places. And again, same thing on the most recent example, going from your original equation to your answer, all you really did was had x and sine of 80 degrees swap places. So to make solving this next one just a little bit easier, let's just consider taking cosine of 12 degrees and y and having those swap places. So that would be that y is equal to 10 over the cosine of 12 degrees. And actually, then you're done. We just have to put that in our calculator. So quite a bit faster if you remember that shortcut. If you don't remember the shortcut, you're just going to have to go through it the long way. But if we take 10 divided by the cosine of 12, we end up with 10.2 to the nearest tenth. Okay, for the last problem, you have to be careful with using that shortcut. Because if you think about it, taking tangent of 68 and 43 and having them swap places really isn't going to help you. You're just going to say that 43 is equal to z over the tangent of 68. So you still don't have z by itself. So don't try to use that trick all of the time, only when the variable's in your denominator. Instead, to get z by itself, we just need to multiply each side by 43. And if we multiply each side by 43, we'll have 43 multiplied by the tangent of 68 is equal to z. So then all we really have left to do is put that in our calculator. So 43 multiplied by the tangent of 68 degrees is 106.4 to the nearest tenth. All right, guys, that's all I've got for you today. Until next time, have a great rest of your day.